Good day! Today, I will provide a brief demo on multiple linear regression in the health insurance datasets. So first here is a preview of our datasets. So our datasets consist of 8 attributes and 1,339 records. And here are the attributes. The teen, or the tax identify number, the, the age of the person, the sex, whether are male or female, and their BMI, or the body mass index, then the smoker, yes, whether yes or no, the region, and lastly, the charge, which will be used as our target variable. Now we're going back to our design. So these three operators was used in data cleansing since our smoker column was in nominal value. So we perform data cleansing in order to make the smoker attribute into numerical values. Now, after we do the data cleansing, we're going to do next is to get the correlation matrix of our dataset to see the relationship of all attributes. Now, in the operator, we select correlation matrix. Then, drag. Then, select all attributes. Then, run. So, this is our correlation matrix. We can see in the correlation matrix, first thing from what we can see from our matrix is that we can see a diagonal entries which a value of 1. This one is represent the correlation of each variable with itself. This is known as autocorrelation, and it always equals to 1 because a variable is perfectly correlated with itself. Next, we can see also that the charge and smoker has a negative and strong relationship of negative 0.7887. Other than the most of the attributes have a weak relationship, and some are somewhat moderate like charge, age, BMI, and charge. Now we're going back to our to design to perform multiple linear regression. After the correlation matrix, we perform the multiple linear regression operator. Now, going to operator, we search select attribute and drag it. Then, in parameter, select a subset. Then select. In selecting attribute, we select our independent variable X and dependent variable Y. Now, we select our independent variable X is age, BMI, and smoker. And as our dependent variable Y, charge. Now, apply. Now, after select attributes, we can run it. Now, this is the attributes that we choose or select from our datasets that are we going to use for our multiple linear regression. Now, we're going back to our design. Then, we set the role, then drag it, then edit. In selecting set role, in the attributes name, we select our dependent variable in attributes from our dataset chart. This is our dependent variable y, then the target role is a label, then apply, then run it. And this is the our dependent variable y, the charge. Now we're going back to our design. Then after set the role, we split the data. In split the data and edit the numerate. In split the data, we assign a 0.7 as our training data. And then we add entry 0.3 as for our testing data. Then apply. Then run. Then we're going back to the design. Then after the split data, we apply the multiple linear regression. After that, we go back to the operators, then select multiply. Then now we apply the model. Then we rename this as our training apply. Then after that, we select performance model. And then rename it as train performance. Then, after we put the train performance, then we can run it. Now, in our train performance, we can see the correlation, which is 0.863. After applying the multiple linear regression, here is the performance based on the training data. We found a coefficient of determination R squared of 0.863, which correspond to roughly 86.3%. This is indicate that the independent variable in our model can account for approximately of 86.3% of the variability in the dependent variable. Now, we're going back to our design to do the testing data. Now, in the operator, we apply the model. Then, we rename it to testing data. Then, apply the performance. Then rename this as testing apply. Then run it. Then after we apply the testing apply model, we can run it. Yeah. Based on the train, based on our train testing data, this is the predictive prediction of charge number. In testing apply, we can see in the charge of 4,449.462 and the prediction in testing data is the prediction is 6,396.102 compared to the train data of prediction is 6,396.102 compared to the testing data. Now, we going back to our testing data to apply or to see the correlation na they can run it. So in the testing data, we can see the correlation when you use multiple linear regression on our data. We obtain a square correlation coefficient of 0.868, which translate to around of 86.8%. This indicates that roughly 86.8% of the variability in the dependent variable can be accounted for by independent variable in our model. So that's all. Thank you.